All right, let's begin. Today we're going to go over 6.7, which is the truth assignment test, which is an alternative tool to test an argument for validity without using a truth table. On Wednesday, we'll do 6.8, I believe is what we're scheduled for. On Friday, I'm going to provide an alternative assignment, and we're not going to meet in person. I'll also point out that Friday is a major holiday for anyone who's a Christian. So if you tell me that you're going to be celebrating the holiday, that means you can have the day off and be excused. Let's see, what else? Oh, this summer, I know finally we're doing registration for the summer and fall. This summer, I'm teaching the exact opposite of this class. So for some of you, you'll be very disappointed, but others, you might be really interested because of that. I'm teaching my movies class, Philosophy in the Movies. It will be in the June term, asynchronous. It is an upper level writing intensive course, which means no matter what your major is, it fulfills a general writing intensive requirement. I think in general, people are required to take 2, unless they're like in the honors program or something. And especially if you're in like a hard science, often there aren't writing classes in your major. So this is welcome to non-majors. I try to make it, frankly, somewhat fun. I try to do movies that aren't like weird and artsy, but are things that you might actually have seen somewhere. So for example, I do a Disney movie. I usually do The Lion King. I usually do a superhero movie. I usually do Batman: The Dark Knight. I usually do a movie about skepticism, which frankly is usually a little weirder than the other movies, but I usually do something like The Matrix or Inception. I do a session on can robots be persons, as depicted in many science fiction movies. I usually do a session on courtly love and Game of Thrones and the politics of Game of Thrones. I usually do a musical. In the past, I've done Les Miserables, although I might be deciding that movie's a little too long and that we need to do something a little shorter. Maybe I'll switch to The Greatest Showman or something like that.
You ever tried Chicago?
I just don't enjoy Chicago. It's one of those things where I have to like at least one of the characters to enjoy a movie, and I just despise every person in that movie is a horrible human being, except maybe the pathetic ex-husband who's just kind of a loser. Well, you got the point, I guess. But in any case, yeah. So yeah, I mean, I'll be honest. I show movies that I enjoy, as that comment just revealed, but movies that I think there's genuine academic interest in, And I already mentioned Game of Thrones. I've literally edited a book about Game of Thrones. I'm considered a national level expert on Game of Thrones. They were going to fly me out to some Game of Thrones convention in San Diego right before COVID hit. So that's the thing I'm on from COVID. That and the fact that my 3 K-12 kids are stuck at home on virtual school. But anyway, enough about my problems. Anyway, so that's in June. If you're interested, great. If you're not, no big deal. Yes? Is it an online course? It is an asynchronous online course, which means you can take the class from anywhere and you can watch the videos at any time. And if you need more help, I'm always available for a video call. So, it's meant to be optimally flexible. All right, cool. Truth assignment test. So as I mentioned in the introduction, truth assignment test is an alternative way to test an argument's validity without using a truth table. Here's what the point of the test is. Essentially, what you're going to try to do is you're going to try to force an argument to be invalid. So remember, the magic formula for an invalid argument is when all the premises are true, but the conclusion is false. So we're going to try to attempt to force an argument to be invalid. And if we fail in forcing the argument to be invalid, then the argument, therefore, is valid. So step 1 is we assign an invalid set of values. So here is a very basic, very simple argument. L or R is true, not L is true, and R is false. This argument in English is probably something like, we should either go left or right, but we should not go left, therefore we should go right. So what we want to do is go through the individual statements and try to assign values to the letters based on what the letter value has to be in order for the statement to have the value we've assigned to it. So first we look at premise 1, which is L or R. And it turns out that premise 1 isn't really that helpful for us. Why isn't it that helpful? Well, we want to force the statements to be true, the premises to be true, but the first statement has too many ways to make it true. The L can be true, the R can be true, both could be true. And because there's so many ways to make statement 1 true, we just kind of bypass it for the time being and push on to the other statement. So premise 1 just isn't that helpful. Then we look to premise 2. Premise 2 is that L is false, and we want this claim to be correct. So for L to be false, for that to be a correct claim, we need to assign 0 or false to L. So we're going to set the value of L to false. And here's the important thing. When you set a letter value, you need to set it to that value throughout the argument and not just in the specific statement. So here you can see we've added superscripts of 0, which means false, to L everywhere in the argument. This will be important later because we're going to go back and reassess premise 1 to see if we've succeeded later on. All right, so we've looked at premise 2. We bypassed premise 1. Let's look at the conclusion. What does R have to be if the conclusion is going to be false? Well, that's actually pretty easy. Since we want the conclusion to be false, and it's just a simple letter R, obviously we need to assign the value of 0 to R in the conclusion and throughout the argument. Okay, we have now gone all the way through the argument, and we have values assigned to each of the letters. The key question is this. We already know premise 2 is true. We already know the conclusion is false. The big million-dollar question is premise 1 still true when we've assigned those values to L and R? And the answer is no, it is not. Because the premise is L or R, and we need at least one of the two to be true, but neither is true. And if we were to switch one of the values, then it would mess up the truth pattern of either premise 2 or the conclusion. So we have attempted to force an invalid set of values on this argument, but we have failed, which means, therefore, that the argument is valid. Let me pause. All right, so you see what we did there? You see why we did it? So again, the goal is to take an argument, any argument, in propositional logic, and to force it to be invalid. To force it to be invalid, we're going to try to force each premise to be true, but the conclusion still be false. And if there's even one statement that departs from that pattern, then it does not work. It does not make the argument invalid. So after we've attempted to assign statement values, letter values, every way that we can to force the invalid pattern on it, if we've still failed to make it invalid, then the argument is valid. Let's do another one, this time with an invalid argument to see, again, how it works. So again, this time, the argument is either L or R, not L, therefore not R. And this will be an invalid argument. So we do the same thing. We assign the premises to true and the conclusion to false. We then look at premise 1 and ask, can we figure out what the values have to be in premise 1 for the premise to be true? And like last time, premise 1 isn't all that helpful. In fact, I think in like all of the exercises, premise 1 is never helpful. Because again, there's too many ways for premise 1 to be true. It's true if the L is true, it's true if the R is true, it's true if both is true. Now, in contrast, if premise 1 was an and statement instead of an or statement, then it would have been really helpful. Because if the claim was L and R, and that claim is true, well, there's only one way to make that statement true. The L has to be true and the R has to be true. And if that were the case, I would immediately put a true in for both the L and the R and plug it in throughout the argument and then see if that worked. But we don't have that. So again, we look at premise 1. Premise 1 is not helpful. We proceed to looking at premise 2. Premise 2 is that L is false, and we want that claim to be correct. So for not L to be the case, L must be false in premise 2. So again, we set all instances of L to false. So we plug in 0 for the premise 2 and also at the L at premise 1. We then look at the conclusion. We want the claim not R to be false. So for not R to be false, we need R to be true. We plug that in at the conclusion and at the premise. And we make R true in all instances. Then finally, we reevaluate. We already know premise 2 is true. We already know the conclusion is false. We just have to look at premise 1 and ask, have we succeeded in making premise 1 true? Because if premise 1 is true, then we have the magic true, true, false pattern, which makes the argument invalid because all the premises would be true, but the conclusion would be false. And yes, since the R is true, the OR is true, which makes premise 1 true, which makes the argument invalid because when R is true and L is false, all the premises are true, but the conclusion false. All right, I'll pause there. So what do you think? Questions about how the truth assignment test works? Do you understand what we're trying to do, why we're trying to do this? Yes, sir.
On the test, are we gonna be able to like choose which test you prefer, or are we gonna master both?
I'm going to encourage you to master both, because it's certainly true that you could, in principle, use either. But sometimes one will be much easier and quicker to do than the other. So let's say, in my sick little mind, let's say I give you an argument where I've got like 6 letters involved. And I've got one premise with like, I use all 6 of the letters. And then the other ones are kind of simple, like 1 or 2 letter statements. Well, in that case, it'd be really good if you knew how to use the truth assignment test. Because if I give you 6 letters, you know how many lines your truth table would have to have? A lot. 2 to the 6, let's see. 2, 4, 8, 16, 32, 64. Your choice would be either a 64-row truth table or do the truth assignment test. So all that to say, you're right. You know, you don't, I'm not going to force you to use one or the other on the test. But it's really good if you have all the tools in the toolbox. Because you never know what kind of crazy thing the logic professor will do. Other questions or thoughts on this? Maybe more simple. How many of how many of you did the exercises and felt pretty good about it? Good. How many of you had some trouble with the exercises? All right, that's fair. All right, well, we'll keep working, but if those of you that struggle a little bit with the exercises, feel free to ask a question when I do something that you don't understand why I did it. That's when your hand should shoot up, and you should say, Silverman, what the hell? Right. Or if you want to be more polite, that's okay. But you can say, well, why did you do that? Help me understand. That's the key moment for you to ask a question. All right, here, let's do one on the board. It is not the case of N triple bar H, N, therefore not H. All right, help me out. What do I do first? Yes. Good. Set all premises to 1. Set the conclusion to 0. What do I do next? Yes, sir. What do I do next?
You look at the values of the variables.
All right. So I try to figure out the values of the individual variables. I look at premise 1, and as the pattern continues, premise 1 isn't too helpful. It's too complicated. It's not gonna. It doesn't force the letters to be just one thing. There's probably 2 combinations where that's going to be the case. So I'm going to look at premise 2. And premise 2 is really helpful because I need premise 2 to be true. And since it's just an N, I'm going to set N to true. But I don't just set it to true in premise 2. I also set it to true in premise 1. Then I look at the conclusion. I need not H to be false. So for not H to be false, I need H to be true, which then gets negated to false. All right, I know that premise 2 is true. I know that the conclusion is false. I then look at premise 1 and ask, have I successfully forced an invalid set of values here? I have a triple bar. It's the same on both sides. The triple bar is true, but it's negated to false. Which therefore proves that the argument is valid. Because there's no way with consistent values for me to get both premises true with the conclusion false. Got it? All right, what's another one that you'd like to see me do? Why don't you pick the ones that you thought were weird or troubling? 4. All right, 4. Oh, yeah. P, therefore P and Q. All right, now first, again, this is where it helps just to take a quick look at it and think about this argument in like terms of English. This claim from proposition, from the premise that's just one proposition, supposedly we're going to prove that that proposition and one that appears nowhere in the argument is also true. I'll give you a hint. This is automatically a bad argument, and it's going to be invalid. But let's do the truth assignment test in order to prove this. We do the exact same thing that we do in every other case. We set the pattern to invalid, which means all the premises must be true. In this case, there's exactly one, and the conclusion false. We look at premise 1. This time, premise 1 is actually helpful. So for premise 1 to be true, P must be true. We plug that in everywhere. Then we look at the conclusion, and we say, is there a way to force this conclusion to be false? We need this and to be false. For this and to be false, the Q must be false. And when we do that, we then look again and say, the premise is true, the conclusion is false, the argument is therefore invalid when P is true and Q is false. So how's that? Does that help? Was it just weird because there's just one premise? Yeah, that's right. So there's nothing else to set it. So you have to set it in the complex, the more complicated statement. Yes.
Do you do 7? Or we do kind of the same thing?
Yeah, let's do 7. Let's see. Let me erase. All right, 7. If both W and C, then Z, not Z, therefore not C. All right, so step 1, as with everything else, we're going to assign an invalid set of values to this, which means both the premises have to be true, but the conclusion has to be false. Step 2, we look at premise 1, and that's really complicated. We don't want to mess with that if we can avoid it. So let's press on. We'll look at premise 2, and we ask, how do we make premise 2 true? For not Z to be true, Z itself must be false. Then we look at the conclusion, which is not C. We want not C to be false, which means C itself must be true. All right, now this one's easy. What you actually have to do here is you have to try plugging in both values for W. And if either value works, then we succeed in making the argument invalid. And in truth, either value works. And here's why. No matter what happens, this is an and statement. And when the W is false, this and will be false. Oh, wait, did I copy that down wrong? Yes, I copied that down wrong. Oops. That makes more sense. All right, so we need to plug in both sets of values. We need to try to find if there's a value which makes this arrow true. Now, since the z is false, we need the left side to be false for this arrow to be true. So we try plugging in both the false for w and the true for w to see if either works. And it will work with a false. So the and is false when 1/2 is false. So if the w is false, the and will be false. Since the left side of the arrow is false, the arrow will be true, and the argument will be invalid. But yeah, so sometimes when you come back to the premise, if there's an unset variable, you have to just do trial and error and try both values. And if either value works, then you've made the argument invalid. Yes, ma'am.
So if W was equal to 1, would that make the argument valid? I'm just confused on what happened there.
So yeah, so what I did is I looked at both possible values for W. And if W were true, that would make the and true, which would make the arrow false, which would make the premise false. So since our goal is we're trying to force the argument to be invalid, so then I went back and I tried the other value, and I succeeded in finding a value where the premise was false. I'm sorry, I found a value where the premise is true rather than false. So the goal is to force it to be false. So if there's anything else you can try to force it to be invalid, you keep trying. If you've tried everything, then you say, oh, I guess it's valid. You're making me hungry. Whatever's in there's got to be good. All right, what else can I try for us? Yes?
Try number 3 from the translations.
Sure. 6.7b. 3. Oh, St. Anselm. All right. All right. If God exists in the understanding and not in reality, sometimes these are easier to translate if you look at the latter premises first. There can be conceived of being greater than God is false. So I'm going to start with premise 2. Not C is false. God exists in the understanding, U. God exists in reality, R. All right, let's look at this wacky first premise. If God exists in the understanding and not in reality, if U and not R, then there can be conceived of being greater than God, C. Yeah, there we go. All right. So the argument is, if God exists in the understanding and not in reality, then there can be conceived of being greater than God. But there can be conceived of being greater than God is false. God exists in the understanding, therefore God exists in reality. All right, let's look at premise 1, and we say, oh my God, what is happening with premise 1? I don't want to mess with that. Set the values of all 3 premises to true, the conclusion to false. We make not C true. We make C false in all instances. We make U true. Assign true to U in all instances. We make R false. We make R false in all instances. All right, so we've got premise 2 and premise 3 true. We've got the conclusion false. Now we want to try to make premise one, true. All right, so we've got an and statement. It is true on the left side. The R is false, but gets negated back to true. So both sides of the and are true. So we've got true on the left of the arrow, we got false on the right of the arrow. So basically, if you assign the values to premises 2 and 3 in the conclusion that you need to get them to be in the invalid pattern, you forced the premise 1 to be false rather than true, proving that the argument is valid. So, there we have it. Argument is valid. It's weird as all get out, but it's valid. Actually, if you want to see one that's really weird, look at exercise A, number 15. In fact, I'm going to do that one because I think it's kind of cool, but deeply disturbing if you understand what's going on. So let's look at 6.7a. Premise 1 is true. Premise 1 is A. Premise 2 is not A. Therefore, B. Let's test this argument for validity. Make both premises true and the conclusion false. Let's start with the conclusion because that's easy. Making the conclusion false is easy, just make B false. But let's look at what's going on with premises 1 and 2. If I make premise 1 true, what happens to premise 2 if I make A true? Premise 2 is false if I make A true. But what happens if I try to make premise 2 true by making A false? Well, then premise 1 is false. Therefore, the argument, disturbingly, is valid. Or to say it differently, from the contradiction, A is true and A is false, literally anything and everything follows. And this is an important principle that will be invoked in chapter 7. From a contradiction, anything follows. So because of that, I mean, this is like, working with infinity in physics or math. If you get it, some really wonky things start being the case. All right, that's 15. What else can I do for you? All right, well, let me see how you all doing. Truth assignment tests. Show me on your fingers. 10 being, I get it already. Let's go do something interesting. 1 being, what the hell are we talking about? Show me, scale 1 to 10, how well you've got this. All right, we've got a lot of 9s and 10s, some little less, some 6s and 7s. Nobody just on one hand, no middle fingers. All right, that's pretty good. All right. Are there other problems that we can go over to help you out with this? Yes. 12 on B. All right. All right, so we've got 3 premises and a conclusion, and I'm going to do what I did last time. I'm going to translate everything but premise 1 first, because premise 1's complicated. Capital punishment doesn't reform the offender. That's premise 2, not R. Capital punishment doesn't effectively deter crime. not D. Capital punishment isn't justified, not J. All right, let's look at premise one. If capital punishment is justified, if J, and justice doesn't demand a vindication for past wrongs, and not V, not vindication, then capital punishment either reforms the offender, R, or effectively deters crime. Yeah, I see why that one is a little weird. All right, so, all right, let's start the same way we did with everything else. We want all three premises to be true with the conclusion false. We want not R to be the case, so we need R to be false. We need not B to be the case, so we need D to be false. We need not J to be false, so we need J to be true. All right, now we want to look at this and ask, is there a way to make this premise true? And there is. B. So this side's going to be false. So we don't want the and to be true, because that would make the premise false. We need the and to be false. For the and to be false, we need the B to be true. Because the B is true, it's negated to false, makes the and false, which gives us a false on the left side of the arrow, which makes the premise true. And then when we do that, the argument is invalid when J is true, B is true, R is false, and D is false. Was the problem the translation of premise one? Yeah, they had all those contraction knots. How much time did you spend on these exercises? How many of you spent a half an hour or less on the exercises? How many of you spent an hour or less on the exercises? How many of you spent more than an hour on the exercises? All right, well, that's not too bad. I will say, after you've worked on it more than an hour, if you feel like you've fundamentally gotten it, you've got my permission to stop and just say, worked on it for an hour, just write down that you worked on it for an hour. Because my goal isn't to dump busy work on you. My goal is to give you enough practice to help you reach mastery. But, you know, I understand you have 4 other classes or more. All right. Well, that's it for today. I mean, I could call you all up to the board and make you do more, or I could do more if there's anything else that's bugging people. I could tell you about this. You can talk about St. Anselm's ontological arguments if you wanted. That's always a fun one. Question? Yeah. Well, we've got 1 month left. Push through and work hard. How are people doing? Is life easier now that spring is here? I don't know about you, but I know February was awful. I mean, it was just cold and dark and not pleasant and exhausting. I mean, I'm still tired, but the bright light of the sun in spring, that's just really good for my soul. All right, well, nobody's particularly talkative today. It's a Monday, and everyone's whispering to each other, don't say a thing, he'll let us go. Nobody wants to be the jerk that makes class last another 3 minutes. I'll be that jerk. All right, good luck. See you Wednesday. Dismissed.
Will do. I think it's 6.8 for next time. They still have not installed my software on here. I've asked them to multiple times. I need to go read someone the riot act.